Good morning, student. Namaskaram. Today we are going to discuss 12th physics. Okay. So chapter name ray optics. Topic name formation of image in simple microscope. There are many optical instruments used in our daily life. So we know that microscope, telescope, spectrometer, okay, and as well as our human eye, okay. So simple microscope. So simple microscope means it is a simple microscope. So SM, okay, is a single magnifying, that means convex, okay, some convex magnifying convex lens of small focal length. Already we know that f, yeah, this is a symbol for focal length, small focal length, so which must produce an erect virtual and magnified image. This is a basic principle behind that simple microscope. Okay. So suppose one object in front of the simple microscope, that simple microscope must produce that image that is erect, virtual, magnified of that object. Okay. So simple microscope is a single magnifying that called as convex lens. We know that convex lens. Okay. So convex lens are small focal length. Hence, object must be placed. So to produce a erect virtual magnified image, object must be placed in front of the lens, but must be placed within the focal length f. That is within focal length means f. So between focus and pole. So here between F and P, object must be placed to produce this type of image. Okay. So the object must be placed within the focal length, that is known as between the points F and P. F means focus, P means pole on one side of the lens. And we viewed through the other side of the lens. Okay. So in this case, we have two types. One is near point, another one is far point, farthest point. Okay. So nearest point means where the eye can clearly see. It is called as near point. And farthest point up to which an eye can clearly see is called the farthest point. Okay. So near point means we can clearly see that object. Farthest point means we can clearly see that up to some distance. For normal healthy human eye, near point means 25 centimeter. For farthest point, infinity. Before 25 centimeter, suppose one object is placed, our eye get strained. Okay. So the eye is least strained when the image is formed at a near point. That is again above the 25 centimeter. So 25 centimeter is the nearest point or near point. Infinity is the farthest point or far point for the healthy human eye. Okay, right. So image formation in simple microscope classified as two cases. One is near point focusing, another one is farthest point focusing. First one, near point focusing. Okay. Already I told you, near point means the eye is least strained when image is formed at the near point. So that is 25 centimeter. So the eye least strained. The near point also called as least distance of distinct vision. Okay, it is also called as least distance of distinct vision. Distinct means clearly. Okay, distinct vision. So object placed in front of the lens within the focal length, and the object distance should be less than the f. Yeah. So image is formed at some position which is near point. Okay. So I will draw one diagram related to this. So this is convex lens, magnifying lens. This is principal axis. This is F. This is okay. So this is P pole. Okay. The distance between focus and pole is already we know that focal length F. So object is placed must be placed in front of this lens, but in between that uh, F and P. Okay. So there is some object. So object here and pole here. So the distance between object and pole is U, denoted as U. Okay. So light rays coming out like this. One light rays going through it and passing through this. Another one light rays passing through this focal pole. Okay. But it appears diverge from that position. So in this case, here meets. So this is a image. Okay, this is image. This is object. Okay, oh, image I. So the distance between image and pole is V, and it formed at that uh, D. Okay, so this is also is denoted as D. The image distance is a near point. Okay. So the object placed in front of the lens between the F and P. The image is here. Sorry, object is here. Image is formed at here. It is a erect, virtual, magnified image. So magnified means enlarged. Okay. Object distance U, image distance V, and we can write as D. Image distance because D is near point for the human eye, 25 centimeter. Okay. So the magnification here, M, magnification M, denoted as M. Already we know that M is equal to V by U. And M, V is replaced by D, and U is replaced by minus U. Because minus sign is there for it measured against that to the left of the lens. Yeah, against the incident ray. So already we know that sign convention. So minus sign is there. So minus cancel. M is equal to D by U. So M is equal to D by U. we can substitute this m is equal to d by u in that uh, equation of length. Yeah, length equation. Already we know that length equation is 1 by v minus 1 by u is equal to 1 by f. Yeah. So in this case, we can multiply v. Okay. So v, v. So v by v, 1. So 1 minus v by u by v by f. Yeah. Okay. Already we know that m is equal to v by u. So we can replace v by u by m. Next step, in the next step, minus m goes here and v by f goes here. So 1 minus v by f equal to plus m, because minus goes into that equal. So plus, and v by f plus here comes, so minus is there. 1 minus v by f is equal to m. So we can replace the v by minus d. Yeah. V is equal to minus d, because sign according to the sign convention. So we can replace v by minus d. Minus into minus plus d. So 1 plus d by f, which is the magnification. This is the magnification for the near point focusing. M is equal to 1 plus d by f is the near point focusing magnification. For the second case, for the second case, it is normal focusing. So normal focusing means the eye is most relaxed when the image is formed at infinity. Yeah. For that image at the infinity, our eye is most relaxed. Yeah, to see that image. So this is called normal focusing. The focusing is called normal focusing when the image is formed at infinity. So here image is not there. So because image, so dot 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 means it is formed at infinity. So this is normal focusing. So in this case, magnification m. Okay, to find the magnification m, we take that height of the object and the height of the image. That means h dash by h. H dash means image of the height of the image. H means height of the object. Okay. So in the case, magnification like only d by f. Okay. Only d by f. No one is there. Okay. M is equal to only d by f. This is a magnification for normal focusing. The magnification or normal focusing is one less than that near point focusing. Okay. So this is the important points related to that concept, simple microscope. Simple microscope, it consists of only one convex lens of small focal length. It is also called magnifying lens. Okay. This magnifying lens. The object is placed between the principal focus f and optical center of the convex lens. Okay. The light rays coming from the object and parallel to the principal axis and refracts. So image is formed at that two position. One is at infinity, another one is image at near point. Near point means for a healthy human eye, 25 centimeter. Yeah. So image is formed. So image, virtual, erect, and magnified image as shown in the um, microscope. Okay, simple microscope. This is a concept. Okay. Okay. So this is another one 4 mark. We will discuss another one question in next class. Thank you. Jai Bharat, Jai Hind, Jai Vidyashati.